Another beautiful question, guys. Let's draw the whole diagram and visualize this. It's again a common sense thing. We're just using vector law of addition here and common sense. Keep that in mind. And let's see how to read the question, formulate the whole idea, draw the diagram, and how the diagram can tell you what to do and how easy it is. Alright, so prove that the sum of the three vectors determined by the medians of a triangle directed from the vertices is 0. So what exactly is this? Sum of three vectors determined by the medians of a triangle. So basically we do have a triangle. So let's draw a triangle. So that's a triangle for me. Okay, let's say that is A, B, and C. Then it says the medians, sum of three medians of a triangle. So the medians are nothing but the line joining any vertex and the midpoint. So we understand that is one of the medians. So I can write that as AD is a median. Like that we have BE is a median. All right, that is E, and CF is a median. So that's exactly what it's talking about. Beautiful. So let's say that is F. So what am I supposed to prove in this? That is vector AD plus vector BE plus vector CF is equal to 0. This is exactly what I'm looking for. Now what is that I know in this case? If I have to find the vector AD, okay, this is something interesting. We actually learned this. Take this as a law and memorize this or keep it in mind. If at all I have two vectors, let's say that is AB here, and you have another vector C in this case, that is AC. And if I say that is the midpoint of BC, we already did this in one of the problems before. So I can write that the sum of these two guys, that is vector AB plus vector AC, is nothing but 2 times vector AD. Yes, 2 times vector AD. We did this thing. We'll do it again. It's pretty simple. If I go from AB, I can also write AB as AD plus DB, isn't it? Yes, of course I can write that. This is AD plus DB. That's easy. Again, what is AC for me? AC is nothing but AD plus DC. I can write AC as AD plus DC. Okay. And I know that I do have a AD and AD here. Yes, they add up to give you 2 times AD. But what about DB and DC? DB and DC, they actually equal and opposite because D is the midpoint. So I can write DB to be minus DC. I can write AD minus vector DC plus AD plus vector DC. And I can cancel these two guys to give you 2 times AD. Okay, that is one of the proofs which I'll be using right now. If I add these two guys, what am I getting is 2 times AD. Keep that in mind. Beautiful, guys. All right, can I write the similar equation for the median BE? For that, look at this, guys. It's very important. This is where you should be very careful. If you do have A here, B here, and C here, I can write BE, where E is the midpoint basically of AC. I can do this on a condition that I have a vector which goes from like this and like that. It should start from B. It should be BA plus BC is 2 times BE. That's exactly, look at that. It is AB and AC. Right, keep that in mind. So I can use the same law here. I can write BE or 2 times BE is nothing but BA. Be very specific about the direction. Okay, I cannot write AB. It has to start from here. It has to go like that and go like that. So BA plus BC. Oh, that's my second equation. Okay, I can also write this as BA, vector BA plus vector BC has to be 2 times BE. And why am I basically writing this? Because I'm looking for what? I'm looking for AD, that is this guy, the median, BE, the median, and CF also I need. So can I write the same equation with CF? Of course. So if I have to write CF, I should have vectors starting from CA, that is CA and CB. So these two vectors, if I add them, I'll get 2 times CF. So we can write that. CA, that is vector CA plus vector CB is equal to, that is 2 times C and F. Okay, so very, very simple. Now we have 3 equations now. Let me write that. I got this equation here already. I have another equation that is AB plus AC is 2 times AD. And the last one I got was this guy, that is CA plus CB. CB is equal to 2 times CF. Now look at that. What am I looking is the sum of these 3 medians. So if I add the right hand side, I do get 2 common out. I'll get BE, yes, plus AD plus CF, and this is exactly what I'm looking for, the sum of the medians, all right, represented by the vectors. And on the left hand side, I have a BA and a AB. Are these 2 opposite vectors? Of course. Vector BA plus vector AB. Basically, if at all you have a AB like that, if that is AB and that is back BA, if you add these two guys, basically you get a 0 vector, because AB plus BA is 0 vector. We understand that. So this will give me a 0. Like that, you have a BC and CB. So I can write plus, you have BC plus CB. Okay, these two vectors will again give you a 0. And the third one I have is this guy. These two guys are done. We have a AC and a CA. Look at that. I do have a plus AC vector plus a CA vector. So this guy would be a 0, 0, and a 0. I'll get a 0 plus a 0 plus a 0 is 2 times. I do get these guys that are nothing but BE plus AD plus CF. And the sum of these guys is actually 0. We understand that? Exactly, that's what I'm supposed to prove. That prove that the sum of 3 vectors. Which are the 3 vectors? These are the 3 vectors which are representing the medians of a triangle will give me what? Directed from the vertices, it means directed from the vertex, that is AD and PE and CF will be 0. And because if you add these two guys, you get a 0 divided by 2, which is 0. Beautiful, guys.